Hello there. Let's go ahead and finish off the sine, cosine, sum and difference proofs by proving the difference cosine identity. Same diagram as the difference sine identity, okay? We're going to go ahead and start with cosine x minus y. If you did not see the setup for this diagram in the previous video, that would be the difference sine identity, then go ahead and watch it. That would be this angle right here, and that'd be AB over the hypotenuse 1, okay, which is just AB. But once again, we need to work the addition sign in there somehow. This is the key to remember about addition and subtraction for cosine is if there's a minus there, there's a plus there. If there's a minus there, then there's a plus there. Okay, so AB. Well, I noticed the trick that it's made up of two different segments, AF and BF. So AF, I'll actually say plus FB. And so these two right here end up being the two segments we need to look for. So let's go through like we have in the previous three videos. Let's look for cosine x. Okay. Cosine x is adjacent over hypotenuse. So this whole thing right here is x. The adjacent would be AF. Okay, great. That's one of my sides. Oh, no, not AB, AF. AF over, okay, so that'd be here and that'd be AD. Let's go ahead and multiply both sides by AD. That would give me AF is equal to cosine x times AD. Now the idea here being that AD will be related to cosine y somehow. So let's get that. Cosine y. So cosine y is this angle right here. Y is that angle rather. We get AD over the hypotenuse of 1. And that's great because that's just AD. And then we finally get what we wanted. We got AF is equal to cosine x times cosine, oh, didn't change colors, cosine y. There we go. Okay, awesome. So let's go ahead now and work on sine x, okay? Now, this is the pitfall I've fallen through before. Sometimes in preparation, sometimes while I'm recording the video, we're going to use this x value. That's very important to have here. So the opposite is EC. So cosine, or no, sorry, sine. That's the 1,000,001 time I've made that mistake. Okay. So sine x is equal to EC over the hypotenuse, which is DC. Okay, so this would imply that EC is equal to sine x times DC. But notice we don't need EC, we need FB. Well, EC and FB are opposite sides of a rectangle, so that means they're equal. So furthermore, we can say BF or FB, apologize for the inconsistency, is equal to sine x times DC, which means we just now need to get DC, which should be sine y. So sine y is equal to, that's again, y is this angle, that's DC over 1, which is equal to DC, which implies that FB, I'll go in order this time, FB is equal to sine x times sine y, and we'll go ahead and put a box around that because now we can truly finish it off. We had cosine x minus y is equal to, we had AF to begin with. AF was this thing right here, so that's cosine x times cosine y plus FB, which was this thing right here, which is sine x times sine y, and we are done.